So hello and welcome everyone. Today we are going to discuss about statistical characteristic of feedback data, detailed solution and explanation. So the first question we have is question 1, measures of dispersion. Uh, Given three more commonly used statistical measures for characterizing dispersion in student feedback data, example variation in teaching quality scores, lab facility ratings, or peer collaboration effectiveness, discuss how these measures can be computed efficiently in large student databases. First, range. Definition of range: the difference between the maximum and minimum values in the dataset. Computation efficiency: high efficiency big O of 1. Once the maximum and minimum values are known in a streaming database, these two extreme values can be tracked in real time with minimal overhead. Now, we have the interquartile range IQR definition. The difference between the third quartile QR and the first quartile Q1. It measures the spread of the middle 50% of the data, making it robust to outliers. Now, computation efficiency requires finding the 25th and 75th percentiles in large databases. This is efficiently approximated using quantile sketching algorithms like Greenwald-Khanna algorithm, which maintains summary of the distribution using very little memory and allow fast approximate quantile retrieval. Now, we have the third, that is variance and standard deviation. Definition: variance is the average of the squared difference from the mean mu. Standard deviation sigma is the square root of the variance. It indicates how spread out the data is relative to the mean. Now we have the formula of variance. Then computation efficiency. The formula requires two passes over the data, one to calculate the mean mu and a second to calculate the sum of squared difference. This can be solved efficiently in a single pass using Welfort's algorithm, which maintains running totals for the mean and sum of squared differences, making it ideal for large streaming datasets. Now we have question number 2, which is feedback rating analytics. If we have a question, suppose faculty students feedback rating on a scale of 1 to 100 on faculty mentoring effectiveness is given in sorted order 13, 16, 18, 19, 20, 21, 22, 33, 33, 35, 35, 36, 40, 45, 46, 52 and 70. What is the mean rating? So finding the mean rating, we know the mean formula for mean is mod x is equal to sigma x upon n. So sigma x is equal to 580 upon total is 20, which is equal to 29. The average faculty mentoring effectiveness rating is 29. Now what is the median? For median, we know that we have to calculate the median position for n equal to 20. Even is the average of the n by 2, it equal to 10th, and the n by 2 plus 1 11th value. So 10th value is 33 as well as the 11th value is 33. Median equal to 33 plus 33 by 2, which is 33. Now what is the mode of the data? So calculation, the mode is the values that appears most frequently. So the values 20 and 33 and 35 each appear twice. So the mode is 20, 33 and 35. Comment on its modality: bimodal, trimodal, etc. The data set has three modes: 20, 33 and 35 as seen in part C of question 2. Therefore, the distribution is trimodal. This suggests there are three distinct groups of students with common sentiment level toward mentoring effectiveness. Now, the last part, that is 2E, estimate the first quartile and third quartile. So for the first quartile, position P 0.25 equal to 0.25 n plus 1, 0.25 21 5.25. Q1 fifth value 0.25, sixth minus fifth equal to 20 plus 0.25, 20 minus 20 equal to 20. Third quartile, position P 0.5 equal to 0.75 n plus 1 equal to 0.75, 21 equal to 15.75. Q3 15th value plus 0.75, 16th minus 15 equal to 40 plus 0.75, 45 minus 40 equal to 40 plus 3.75, 43.75. Now we have the 2H, 2G and 2H. Summary: the 5-number summary provides a robust description of the data set's shape and spread. Minimum equal to 13, Q1 first quartile equal to 20, median Q2 equal to 33, Q3 third quartile equal to 43.75, maximum equal to 70. 2G, draw a box plot of the data. Explanation of box plot. The box plot displays the 5-number summary graphically with the box spanning the IQR Q1 to Q3 and the line inside marking the median. The whiskers extends to the min and max unless outliers are present. 2h. How is the quantile plot different from a quantile plot in this constant? So the quantile plot Q plot plots the values in the sample dataset against their correlation corresponding quantile ranks or z-scores percentiles in the data itself. It primarily shows the overall distribution shape and helps identify clusters or tails. Quantile plot plots the quantiles of the same sample data sets are student ratings against quantiles of a specific theoretical distribution, usually the standard normal distribution. Now difference in context. So the QQ plot is used specifically to test for normality. If the points on the QQ plot falls approximately on a straight diagonal line, the student feedback data can be assumed to be normally distributed. If they deviate significantly, the data is non-normal. Analysis of the group satisfaction scores. So question 3, approximate median scores. Suppose student lab infrastructure satisfaction scores are grouped into intervals with the following distribution. Compute an approximate median satisfaction score for the students. Score ranging 1 to 5, 6 to 15, 16 to 20, 21 to 50, 51 to 80 and 81 to 110. Frequency for each respectively is 200, 450, 300, 1500, 744. So its first part asks us to compute an approximate median satisfaction score for the student. So score ranging 1 to 5, frequency has 200 and cumulative frequency is also 200. 6 to 15, frequency is 450 and cumulative frequency is 200 plus 450, it is 650. Now 16 to 20 is frequency having 300 and cumulative frequency 950. 21 to 50 median class frequency 1500 and cumulative frequency 2450. 51 to 80 frequency 700 and cumulative frequency 3150. Now 81 to 110, 44 and the cumulative frequency is 3194. Total frequency n equal to 3194. Step 2, identify the median classes. Median position n by 2, 3194 by 2 equal to 1597. The class where CF for 6 is 19. 57 is the 21 to 50 range. Step 3, apply the median formula. Median is equal to L plus N by 2 minus C upon FM into W, where L is the lower limit of the median class, that is 21, N by 2 is the median position, that is 1597, C is cumulative frequency of preceding class, that is 950, FM frequency of medium class, that is 1500, and W class width, which is 50 minus 21 equal to 29. Now calculation. Median is approximately 21 plus 1597 and we have the after calculating we have the approximate median satisfaction score as 33.51. Analysis of lifelong learning data with n equal to 18. So now we have a question, and for this question in the Department of Lifelong Learning, a feedback survey collected both students' age and their self-assessment of learning productivity percent for 18 students. Now we have this table, and according to this table we have to solve the questions. Okay. So fourth A asks us to calculate the mean, median and standard deviation of age and person productivity. So for mean we will again calculate the mod x, that is sigma of x, which is 864 upon my n, which is equal to 18. So 48 years, median stored age 23, 23, 27, 27, 39, 41, 47, 49, 50, 52, 54, 54, 56, 57, 58, 58, 60, 61. So median is 50 plus 52 by 2, which is equal to 51 years. Now standard deviation, sigma calculation. Sigma of x minus x ka square equal to 4780. So sigma of x, that is standard deviation, is 4786 upon 18 whole root, and which is 16.31. Productivity y calculations. Mean y equal to sigma of y 548.8, mod y equal to 548.8 upon my 13, which is approximately 30.49%. Now median is sorted product, that is 7.8, 70, 14.1 and so on, and calculating these values we get 29.5 as the as the median plus 31.2 as the median upon 2 equal to 30.35%. Standard deviation should be calculated in the same way. And now draw the box plots for both. So explanation: two separate box plots are required to visually compare the central tendency, spread and symmetry of the age and productive distributions. Now draw a scatter plot and a QQ plot to study the relationship. Scatter plot plots age on the x-axis and productivity on the y-axis. The resulting graph reveals the correlation positive, negative or none and potential clusters or outliers. QQ plot distribution check used to compare each variable's distribution against the theoretical normal distribution. So that's it for today's video, and now we'll discuss the next set of questions in the other videos. Thank you.